Hi, and welcome to part 2 of this video series where we learn how to do the McCabe-Thiele method in Python. In this section, we'll be taking a look at how we can obtain the equation of the rectifying section as well as the stripping section in Python. So, in order to get that, what we need to understand first is that there is a point in this equilibrium diagram where the three lines, the rectifying section, the stripping section, and the Q line meet at the same point. So, and another thing we need to know is that we already have one particular coordinate of the rectifying section, which is the distillate composition, that means xd comma xd. And then we also know one point in the stripping section, which is the bottoms composition, xb comma xb. Now, if we somehow find this coordinate where the three lines intersect, we will be able to find the equation of both the rectifying section line and the stripping section line. So how do we do that? First of all, what we're going to do is we're going to equate the equation of the rectifying section and the Q line, and from that we will obtain the x-coordinate of that intersection, and by plugging that value into the equation of the rectifying section, we'll be able to obtain the y-coordinate. So these are all of the equations that we'll be using, and specifically in Python, we'll simply be plugging in this equation so we can directly obtain the x-coordinate of that intersection. So let's plug that into Python. So we have our x-intersection, which is equal to xf divided by, that's q minus 1, plus we have xd over r plus 1, and then we divide the whole thing by q over q minus 1 minus r over r plus 1. So yeah, so that gives us the x-coordinate of the intersection. And then to find the y-coordinate of the intersection, we're simply going to be using this exact equation where xi is going to be xi, the intersection. So r over r plus 1, r times xi divided by r plus 1, that's the question mark, it should be a division, and then xd over r plus 1. So plus xd over r plus 1, brackets close. So that gives us the two coordinates of the intersection. So now let's find the equation of the rectifying line. So define REC. I don't know what all the inputs are going to be, so I'm going to leave that blank. First of all, our x values are going to be np.linspace. So for the rectifying section, we just have to go from the intersection xi all the way to the distillate composition, so xd. So I'll say xi, comma, xd, comma, and let's say I just want 51 equally spaced points. And then our y value is going to be, again, we'll just be using this exact equation. And instead of xi, we'll just have that x. And we want this to return x comma y. And as soon as we have that, I'm just going to be storing those coordinates in variables. So x underscore rec and y underscore rec. And we'll get them rec. So this function's inputs are going to be, first of all, xi, and then we'll have to provide xd, and finally r. I think these are the only things we need to provide. We have xi, xd, and r. Yep, that's right. So let's do that here as well. xi, xd, and r. There we go. And same thing for the stripping section. So define a function, str, and we'll, I don't know what inputs we'll be providing, and we calculate the x and y, y. It will also be returning x and y. And again, similarly, we'll store this in separate variables as well. X underscore str, not string, it's a stripping section, and y underscore str, which will be stored under str. Okay, so now how do we find the equation of the stripping section? What we can see here is the stripping section. Once we have the coordinate of the bottoms, which we already do, and we calculated the coordinates of the intersection, we'll just use the straight line formula in order to calculate the equation of this line. So that would be y minus any coordinate in here, which would be xb, equals the slope of this line, which is equal to this yi minus xb over xi minus xb, multiplied by x minus any composition xb. So I'll just be taking this value in order to make it a calculation. I'll just take this and move it over to the right hand side of the equation and make that a plus xb. So we just have to put this equation in. Similarly, the x values will only be ranging from the xb all the way to xi. So let's do that in Python. So x will be np.linspace all the way from xb to xi. And again, I want 51 values. Our y is going to be yi minus xb. So that's yi minus xb divided by xi minus xb, and this whole thing multiplied by xs minus xb. So that would be x minus xb plus we get xb. So that's the stripping section equation. So we'll be feeding in xb and then xi and yi. I think that's all we need to feed to this equation. xb, xi, yi. Yep, that's it. So we'll do the same thing here. xb, xi, and yi. And okay, this looks like there's an error here. Oh, we missed a multiply sign here. There, and everything should be set. Alright, yeah, so we've set up the equations for our stripping and rectifying section.